All right, chemistry, let's take a look at our group activity, the Planck's equations, when I was pretending to be your substitute teacher. Now, the point here is that these mathematical functions are very, very simple, despite their seemingly complex definitions and names. And so, yes, c might represent the speed of light, and it might be this kind of large number with this exponent right here and these units that we don't use in chemistry all that often. H might be Planck's constant, which again is this very, very small number with this unit that we almost never use in general chemistry. It's pretty common in AP chemistry, but the joules seconds, right? Joules times seconds. But then we have things that we have seen before, right? Converting meters to nanometers and then kilojoules into joules. So the goal of this worksheet is to try to teach you to separate, to compartmentalize in your mind things that you can do and things that you can't do. Again, you might not understand what frequency is, but it's certainly very easy to calculate it. You might not know what wavelength is, but it's very easy to calculate it. So I'm trying to differentiate those two ideas. So let's take a look at number one. Ultraviolet radiation has a frequency, again, I might not know what that is, of 6.8 times 10 to the 15th per second, or hertz. Calculate the energy in joules of that photon. Now we know that we're supposed to calculate energy here, right? And the unit's supposed to be joules. Well, in these useful equations up here, we have E is equal to H times nu. E being energy, it tells us so right there. H being this number, it tells us right there. And then this kind of weird looking V, which is actually the Greek nu, is frequency. So what we're being told here, if you read this question carefully and actually look through this information, that we need to use the equation E is equal to H nu. And just so you guys don't miss this, when the known is frequency, notice how the question gives us frequency. When the known is frequency, we use this equation to find the unknown of energy, right? So problem solving strategies right up here for you. Now, Planck's constant, H, is always the same. So all I have to do is plug this number in for the H. Nu, the frequency, was given to me by the questions right here. So I plug that in and multiply the two. Now, in terms of units canceling, frequency is always in per seconds, right? S to this -1, which means that it's the inverse, right? Instead of S over 1, it's 1 over S, meaning this seconds is actually a denominator. Being multiplied by this S in a numerator, they get to cancel, leaving only the joule for my unit, which is handy because the question asked me to calculate the energy in joules. So plug this into the calculator. We get 4.5 times 10 to the -18th joules.